Hello, in this video I would like to show you how to develop black and white film in a very simple way. I think this is good for people who are starting with this hobby and who are not sure what is really necessary and what is necessary and what is not necessary, because on the internet there are a lot of tips, but I get the impression that a lot of people are making it too complicated and are using more things that are not really necessary, at least not for the very first roll of film. You can do it like this for the first 2-3 rolls of film, and then you will notice what you have to improve to get better results. But what I will show you is the bare minimum you have to do to get actual pictures on your black and white film. So to understand what is happening during the development, you have to have a very basic understanding what film is. Film is a transparent piece of plastic. On this transparent piece of plastic there is a layer which contains chemicals which are very sensitive to light, and these chemicals, these molecules, will break up when they get a certain amount of light. So in the areas where light has struck the film, a lot of these molecules will be broken up. In the other areas the molecules will be more or less intact. So in order to get a picture on the film, we will use a chemical which it's called a developer. This chemical will start a reaction where on the places where the molecules have broken up, silver crystals will form. And that means that in these places there will be in the end like little dots. They are made from metallic silver, and on the when this is finished, the development, we will rinse the whole thing so that the developer gets washed out, and then we will use something which is called a fixer, and this fixer will basically remove all the molecules which have not broken up in the moment of the exposure of the film, and it will conserve the metallic particles which have formed during the development in their place. And when the fixer has done its job, the film will be no longer light sensitive. After that we rinse it again with water so to get out all the chemicals, and then we will dry the film. So that's what's happening. So in some tutorials they use a stop bath between the developer and the fixer. The stop bath is like a acid, and it completely stops the development. It completely basically destroys the chemistry of the developer in the film. The stop bath cuts the development. It's interesting for you if you want to stop the development at a certain point, or and it will protect the fixer solution, because the fixer solution will last longer if you use a stop bath in between these two. But from a real world experience view, it's not really necessary, because when you develop the film in the regular time interval, at the end of this time interval, there's not much happening in the of development anyway. So the stopper doesn't really stop anything, or at least there is not much happening anymore. And the most important thing with film development is that you have consistency, so that you are doing the things always in the same way, and so you can change things. You can decide to develop longer or shorter, or change temperature or whatever to change the results. If you are not consistent, you will have no idea if the changes you are seeing are result of your procedure or just random results. So that's the most important thing, to be consistent. Developer and fixer are usually delivered in concentrates. So they are in this state. You cannot use them for development because the concentration is way too high. We will make working solutions. That means we will dilute it with water, and will be working with these dilutions. And the difference between the developer and the fixer at this point is that the developer is one way. That means you mix it, you use it, and then you have to discard it. You cannot reuse the developer. The fixer, on the other hand, you can reuse that, the solution. You can reuse it again and again and again, and you can use it for film and for black and white paper as well. So, for example, this product, Artofix Plus, with the dilution of 1+7, you can use it for film and for paper. And they will, on the homepage of this manufacturer, you can look up how long you have to fix the film or the paper. But I usually don't use these times. I decide by myself. I make the solution, and then I will take a little bit of film, undeveloped film, put it in the solution, and then stop the time. The fixer solution will start to clear the film, because at the beginning the film will be opaque. Then after, like I say, 2 minutes, it will completely transparent, and it will not become more transparent. So I see 2 minutes, and I will double this time, so 4 minutes. I know I have to put I have to fix my film with this solution then 4 minutes. Just an example. And when I don't use the solution for several days or weeks, and I reuse it again, then I will repeat this test. So I will start to make a working solution for my fixer. How many solution do I need? How much? I look at my tank, and at the bottom of my tank there's written how much solution is necessary to cover the film. Because that's important, because you see, these are the spools where I can put in 2 35mm films. They have a certain height. So if I want to develop one 35mm film, the liquid has to be at least this high. And if I want to develop 2 it has to be this high. And if I use the spool for medium format, 2, I need more liquid. So depending on the kind of film and how much of film I develop, I have to look it up here. So I want to develop one roll of 135. 135 means 35mm film. So they say I need 375 milliliters. That's the minimum. I will make 700 because I use the solution also to fix my paper, and there I will need more. So I will make 700 milliliter solution. So 700 milliliters. I looked the fixer up. I recommend 1+7 for film. This solution also can be used for paper, so I will use that. There are other solutions, other dilutions possible for this product. You will have to look at the homepage of your provider, or maybe it's on some bottles it's written. So 1+7, I want to have 700 milliliter. So resembles 1+7, that is 8. So we want to know there are 8 parts, 1 part fixer, 7 parts water, and in sum there will be 700 milliliters. So 700 milliliters divided by 8 parts, that means 7.5 milliliter per part. So I will use 90 milliliters. This doesn't have to be very precise. So if one part is 87.5 milliliters, 612.5 milliliter water, and this is fixer. So I will combine 90 milliliter fixer with 612.5 milliliter water. So that will result in a little bit more than 700 milliliter, but it's not so that the fixer is not doesn't need to be very precise. As a container for the fixing solution, I will use an old water bottle. I removed the sticker and I marked it with F, and you have to be careful. I'm living on my own, so there's no one else here. But if you have children or other people, make sure they don't think it's something that they can drink. According to the or in relation to the poisonous or hazard of this chemicals, you can see them as like a strong cleaning agent. You know, like a strong solution you use to clean your bathroom or your toilet or something like this. It's not super dangerous. You won't die if you get in contact with it, but you don't want to have it on your skin for long periods of time, or most people use gloves. You don't want to have them in your eyes, so you don't want to drink them. They are not the most hazardous thing, but they are also not very healthy in any way. So when you work with them, don't swallow them, don't get them in your eye, and make sure that you have air, some kind of ventilation, or open the window. It's you won't die if the windows are closed, but it smells, and it's not healthy like fresh air. When preparing the fixer, remember that the fixer will completely stop any kind of development. Even very small amounts of fixing solution will completely destroy your development solution. So all the vessels you are using to meter and to contain your fixer, make sure to rinse them very good before you start working with developer again, or in the best way use separate cups and separate funnels if you have them for development and fixer, so you don't confuse them, and you want to rinse them. So I start with the water. We need 612.5 milliliter water. Okay, I think 610 or 615 is good enough. So I use tap water basically. The fixer doesn't need to have a certain temperature. It's okay if it has just some kind of room temperature. So I fill it up to 500. There we have 500. I will pour that in my fixer solution containment. I'm still missing 115. I pour in to 100 and then I add just a little bit. That looks like 115 to me. For the fixer I use this smaller scale. It goes up to 50 milliliter. So I will fill it up with 50 and then another time up to 40. And then I will have my 90. The fixing solution is ready. The fixing solution will last for quite some time. There is a certain amount of rolls of film you can make with this solution, but in my experience, if you are not really developing a lot of films, you will probably not reach this amount, because after some time there starts to build some kind of material on the inside of the bottle, which are like little particles, and once they build up, you will have to filter it very good, or to discard it and get another one, because if you use use the fixer with the particles in it, the particles will end up on the film and they can keep stuck there, or they can disturb the chemical progress. So in my experience, if you develop a few rolls of film, then you probably will not reach the limit of the solution. It will go bad before that, and so that's one of the reasons why I think that stop bath is not really necessary, because you won't really reach the end of the fixer anyway. Now I will wash the funnel and the scale very good, very thoroughly, so that I get rid of all the fixer which is still on them. Now I will start putting my roll in the development tank. For that I need the roll itself, the tank, which contains a spool set up for 35mm film, and when the tank is closed, it's light tight. I will bring the film into the spool, and I have to do it in total darkness. In order to get total darkness, I use a changing bag. You could also use a dark room, but it has to be really dark, and you cannot use the red light during inserting the film, so it has to be really dark. And when you insert the film, there are two possibilities. If you have rewind the film completely into the canister, you will need some kind of tool to open the canister. Do it like you open a bottle of beer, like this. If you have a possibility to rewind manually, you can rewind it in such a way that a little bit of film sticks out still. So this film is not exposed. It's new, but I would like to show you how to prepare the film before you spool it on the spool. You see, if you start putting in the film like this, that won't work. You have to cut. In most tanks, you have to cut the film first, and therefore you need a pair of scissors, and you cut the film in such a way that the perforation is still closed. You see that? If you cut it so that the perforation is open, you might have troubles inserting the film in the spool. And if you left a film out like this, you could then start, while the light is still on, putting in the film like this and advancing it a little bit until the perforation catches, and then you would turn off the light and completely work the roll, the film on this spool until all the film is on, and then you would use again the scissors to cut the film from the empty canister. Also, if you bring the film into the spool, make sure the spool is completely dry. If it's a little bit wet, perhaps because you rinsed it before and it hasn't dried up completely, your film will get stuck. It will be a big mess, and you will not be able to spool it properly. So to avoid disappointments, make sure, usually I don't have to rinse it, because after development you're rinsing the whole inside of the development tank, so it is clean when you extract the film. The spool is usually clean. You don't have to rinse it. But if you do rinse it, make sure it dries up completely. Really, every little edge inside has to be completely dry. In my case, the film is completely spooled in, so I will need a scissors and something to open this can. I put everything into the bag, You have to take care. Usually in the bag there are two bags, an outer bag and an inner bag. So you have to put it really in the inner bag. The film, this stuff, the scissors, and my tank. Then I close the first zipper. And I close the second zipper. Now I can insert my hands into the bag, and now I will start to work. When you cut the film, make sure you don't cut the bag. Okay, I've done my part. Time to open the whole thing. The empty canister, snippets, and here is the tank now with the film in it. It's like tight. In order to know how long I have to fix the film, I use the piece of film I cut off to test the time which is necessary with the fixer. So I have prepared the fixing solution. I pour in something of it. And now I take this piece of film and I will use this metal part here to fix it in the fixer and to see how long it will take to be clear. Okay, I start, take the time, I take the piece of film and put it into the fixing solution. This can be done in broad daylight. So you see that the film starts to get transparent. We have just 1 minute. More and more of the film is transparent. Now we reached a point where I would say it doesn't get more transparent over time, and that's 2.5 minutes ago, about. So that means that it took 2.5 minutes for to clear, and we doubled this time, so I have to wait 5 minutes. I take 5 minutes for the fixer to work on the film. Now I will prepare the developer. I use Adox Adonal, which is based on Rodinal. Rodinal is a very old developer. I usually use it. It's a traditional developer suited for traditional films. So there are traditional films and flat corn films, and I use only traditional films and traditional developers, especially Rodinal. Rodinal is easy to work with. It lasts forever. It doesn't get bad. It's cheap. The only downsides is that It increases the contrast of the film and decreases the total resolution. The films look sharp when you look at them, but they are this sharpness goes on a deficit of total resolution. But I think it gives the pictures the classical black and white look that you probably are looking into. The film I used is Agfa 400 APX. So how do I know how much, what kind of solution I need and how long I have developed the film? You can look it up at the manufacturer of the film or the manufacturer of the developer, but there is a very nice homepage. It's called the Massive Development Chart from Digital Truth Photo, and that's very nice. You can select a film. I have the Agfa APX 400. You can select a developer. I use something which is basically Rodinal. I press search, and here it gives me if I exposed it like 400, I can use a dilution of 1 plus 25. That means in total 26 parts. And it would take 11.5 minutes at 20 degrees. I will choose that. The first question is, how much solution do I need? My tank tells me that I need 375 milliliters solution to develop one roll of 35 millimeter film. So I will take 400 milliliters. So again, we make this little calculations. We have 400 milliliter of the solution, which is 25 plus 1. That means 26 parts. 400 divided by 26 means 15.4 milliliter is one part. There is the possibility to make a dilution of 50 plus 1, which will increase the development time, and you will save developer because then you can reduce the amount of Rodinal you're using, and the lower concentration of Rodinal will also result in less contrast. However, you have to understand that for a roll of film you need a certain amount, a minimum amount of developer. So if you use higher dilutions, you also need a bigger volume of the solution. Water, you need 400 minus 15.4 milliliters, but I will just use 400 millimeter water straight. This little variation doesn't really affect anything. It's more important that you do it always in the same way. That you do it always in the same way. That's more important than if you really subtract this 15 milliliters from the 400. If you always use 400 milliliter water and 15 milliliter, 15.5 milliliter developer, and you're consistent with that, you can from that point change your system to your liking. But if you do it every time a different way, you will never get anything reproducible. This table also says it should have 20 degrees, the solution. So how do we achieve a solution which has 20 degrees? There are two possibilities. Possibility one, tap water on 1 day or 2 days earlier and put it in a place in your home which has approximately 20 degrees. So if you start pouring it, the 400 milliliters, into your measurement, and you start measuring the temperature, you will see it has 20 degrees. If you that only works if this room has a constant temperature, of course. But in some cases, when it's very cold or very hot, maybe this room doesn't have 20 degrees. So how can we get in another way 20 degrees in a simple way? You can get a cup of 400 milliliter water or whatever volume you want with 20 degrees by mixing two other waters, a water which is colder and a water which is hotter. So I have here a volume 1 with 37 degrees and a volume 2 with 14 degrees Celsius. So how much of volume 1 and volume 2 do I have to mix to get 400 milliliter with a 20 degree in here? So we can make a little calculation. So we have volume 1 with a temperature 1 of 37 degrees and volume 2 with a temperature 2 of 14 degrees. We want a volume desired with 400 milliliters and the temperature desired of 20 degrees. The formula for to get volume 2 is volume desired multiplied with temperature 1 minus temperature desired divided by temperature 1 minus temperature 2. And of course volume 1 is volume desired minus volume 2. So in this case we will take volume 2 is 400 milliliter. Volume desired is 400 milliliter multiplied with temperature 1 is 37 degrees minus temperature 2 is 14 degrees. Temperature desired is 20 degrees divided by temperature 1, 37 degrees minus temperature 2 is 14 degrees. So I made a quick calculation. I get 295.6 milliliter of volume 2. If I put 295 milliliter of volume 2 in here and fill up the rest to 400 milliliter with the volume 1, I get 400 milliliter with 20 degrees. So let's put that to the test. Now I fill up the rest. And voila, I get 400 milliliter with 20 degrees Celsius. Now I will mix the development solution. I open my developer. I'm supposed to fill in 15.5 milliliters of developer. Don't be afraid if the developer turns very red or if there's something audible inside the developer. That's normal if it gets old, but it's still working. I'm talking about Rodinal here. The other developers are probably not as durable. I pour in the developer. Now everything is prepared. I have my development solution, I have my fixing solution. The film is in the development tank. Now I start developing. Usually I would do that in the bathroom, but here it's easier for me to film it, so I will use a big bucket to collect the water, and I prepared process water. This is tap water I tapped 2 days ago. They have everything here has 20 degrees because I stored it here in this room. It has 20 degrees, so I will start by inserting just water. This water will rinse the film, so the layer which is on the film will soak itself up with water, so the chemicals inside can accept the developer and the fixer easier. And sometimes there is a kind of chemical layer on the film, so I think that has advantages. Also, when the film is still dry and you pour in a liquid, since the film is very close together, there can form bubbles of air, and they will mainly form when the film is still dry, when there is still a lot of air in it, and when the film is wet, the danger is not that high. So I will start with pouring in approximately a little bit more than 400 milliliters of water in the tank. I close the tank again. I rotate it a little bit. I put it on the surface, so this shock will shock loose all kind of bubbles which are inside between the layers of film here. I don't take time with this step. I just leave it there for about a minute or something like this. It's not really critical. Okay, now I'm done with that. I put it into my bucket. Now I'm ready for the developer. So the chart tells me 11.5 minutes. I start stopping as soon as I begin pouring in the developer into the tank. So it, close it. There are several procedures how you move the tank while it is developing. I usually move it more or less constantly in the first minute, and then every full minute I will just turn it a few times until the develop time is over. There are other procedures where you just let it sit like in the tank without any moving, with very low concentration of developer. This is supposed to give you less contrast and higher resolution. Sometimes I'm doing that too. Okay, time is over. I remove the developer. So the developer is out of the tank, but technically the development is still going on. A lot of people say now you put in the stopper, and the development time stops when you pour in the stopper. I think that at this point there isn't much going on in the development department anyway. So I just rinse it with water to dilute the developer a lot. And after that I will pour in the fixer, and in my opinion that's for that. Now I have poured in fixing solution from my fixing bottle in this cup, and I will pour in the fixing solution into the tank. I start stopping the time. Earlier I determined that 5 minutes for my fixer is enough. So I mixed it 2 times during 1 minute, and now for the rest of the 5 minutes I will just let it sit there. Okay, the 5 minutes have passed. I will pour back the fixer. Now I will rinse the film. In order to rinse it, I will use something which is called the rinsing cascade, which basically means that I will pour in clean water, close it, shake it 2 times, then pour the water away, and then another time fresh water. Now I will shake it for 4 times, the next time 8 times, then 16 times, then 32 times, and then the film should be rinsed. So therefore, of course, you need a certain amount of water, and the water shouldn't have a very big temperature difference to the liquids you used before. So when I want to develop film, I always fill up some empty bottles with tap water, so they have the room temperature, and 1 or 2 days in advance. So I have plenty of tempered water. So I start here. Two. Now the film is developed and rinsed. It's still wet, but it's not longer light sensitive. So you can take it out and have your first look at it. So you can see a lot of nice pictures. Now you just have to hang this film in a dry room, like in a bathroom, and you hang it up. Downside, you use clippers from your laundry, one on the top and one at the bottom, so it will be nice straight and will also dry nice. You can, to remove the water, you can use your both fingers, make like that. There are special tools to make this, and there are also wet agents to remove the water better and to deal with the water if it's if the chemistry of the water is not very suitable. If the chemistry of your tap water contains a lot of minerals which deposit on the film, you can use different chemicals to deal with that. But for your first roll, you can just leave it that way. And at the beginning, the film is sensitive to scratches, and it will, if you put it on a dusty surface, the dust will permanently stick on the emulsion side of the film. So the best practice is to immediately hang it up to dry in a room without dust. Now I'm hanging the film up to dry in my bathroom with a clip on the top. And a clip on the bottom.